Francis. Thank you. Great introduction. I was singing along with Valerie, but they silenced my mic for some reason, so you all were not able to hear my tone-deaf rendition. First of all, I want to thank you all for coming. I know you're taking time out of your busy days. There's opportunity cost for you to be here, but I do truly believe it's a tremendous opportunity. As Francis sort of teed up, you get to see what tons of other people are already doing at scale around the world, both government and industry, and look at that and understand it within the context of what the challenges are that you face today. We've got over 2,000 people registered for today's event. That's twice what we did last year, so if Adrian's in the audience, I want 4,000 next year. We had our first coding at ThinkGov. Yesterday, we had 500 folks for that over in Roslyn, Virginia. I got to wear jeans. It was a great event, and people were diving deep on containers, Kubernetes, AI, and all that sort of thing. So really exciting. If you didn't get a chance to hear Magus, the young man who won the Call for Code last year with their distributed mesh network for areas that had suffered natural disasters, just now deployed down into Puerto Rico. He had just gotten back from that. An incredible design that this virtual group of 5 folks had pulled together. As I said, though, today the focus is to expose you all to what we're doing on an enterprise level at scale around the world. So this isn't small pilots. This is truly operational sorts of things, whether it's on the industry side of the house in financial services or industrial or distribution, communications, or the government side, U.S. federal government, state and local government, and governments around the world. So we do have Sriram here today who heads up global government for IBM, and he's gonna talk to you about some of those opportunities. IBM obviously has been around for a long time, right, over 100 years, and we've had to reinvent ourselves. So much like the federal government, we've gone through these periods of transition as we're doing today. 10 years ago, we were 80% hardware, 20% software. Today, 20% hardware, 30% software, 30% services, and the other 20% is this new quantum, AI, cognitive, the whole other areas that we're moving into. Last year, $5 billion we spent in research and development, once again leading in the United States in patents, 9,100 patents issued to IBM, 1,600 of those in AI, 1,400 of them in cybersecurity, the others across cloud, quantum, AI, blockchain, IoT, that sort of thing. And that's what we're going to walk through today. But as Francis said, the technology's great, but it's how do you put it to work, and where can you succeed, and where perhaps have we found areas where it doesn't work so well. That's what we're going to walk through. In IBM speak, we talk in terms of Chapter 1 for AI and cloud and Chapter 2. Very similar to Cloud First versus Cloud Smart on the federal government side of the house. In Cloud First, we had initial movement, easy workloads to the cloud across the world. 20% more or less of workloads have moved into the cloud environment. It's the easy email sorts of things. What hasn't moved are the very consequential mission workloads, as Francis raised. And so that's what we're looking at now as we move into Chapter 2. It's a hybrid cloud environment. You have IT on-prem, you have private clouds, you have multiple public clouds, all looking to optimize that system. And in a world of containers, that's now becoming much easier to do and seamless across your enterprise. And of course, you then need to all wrap that all in security. So we are going to go through a whole series of presenters and speakers today. We've got 20 demos outside that we will walk through as well. So with that, again, I welcome you, and I believe I forgot to wish everyone a happy Pi Day as well. And now we're going to move into our first speaker presenter. We're going to start out with a short video here first. So if we could roll the video.
And Mom says, when you get back, we can finish the fort. Remember, you have to follow the map carefully. so you can find the keys and get to the treasure. You won't be alone, though. You have a friend who helps you on your adventure. He's really smart and can help figure out where you should go. The giant bird will take you there.
Place on the ground. Task Force 6 is in position. Confirmation that the area is clear.
The sea monster is big and scary. He can swallow houses and cars. But you can face him because you're brave.
Boots on the ground. Bringing the 1st and 2nd Battalion to assist with the evacuation in Sector 12. Let's get this done as quickly and efficiently.
Once you pass the sea monster, you have to climb over Box Mountain.
Successful drop in Area 1. First phase of USAID stock for distribution is approximately 60% complete. We'll prepare for phase 2.
In the dark forest, it's hard to see. Don't worry, your friend can help you through.
The latest readiness reports have been analyzed. Utilizing Watson to shed some light on upcoming unit movements to replace the 22nd. We don't want any surprises.
You're almost there. You have to use all the keys in the right order to open the treasure.
Recalculating overall readiness of the East Coast units. The 22nd is cleared to go on leave.
I missed you a lot.
I missed you more, but Daddy's here now, okay?
So, thank you. So if I could now bring up to the stage the man and the operation behind that video, Franz Gayl from Plans, Policy, and Operations, U.S. Marine Corps, Science and Technology Advisor. Franz?
That's it.
Welcome.
Thank you.
Have a seat. So let's sort of dive deep behind that video. Obviously, deployment and readiness, a huge issue for the Marine Corps. We've been in 18 years of continuous combat, and that's put a strain on manpower, strain on resources, strain on families and soldiers at the end of the day. So let's talk about that problem and how the Marine Corps was handling it and how you're looking now to bring AI to bear.
So first, I'd say that Marines are very good at manual methods. We have been for over 200 years of our existence, and we've been very successful. And it's a pretty high bar that has to be passed for, we're going to be very deliberate about taking in AI technologies in terms of having confidence in them. So that's a slow process with this, a very deliberate process. We're also very operational, and getting to the issue of managing, we're also very operationally focused. So we don't have very many margins for error. There's very little margin of slop, surplus, et cetera. And so we have to have great confidence in the business intelligence that we take in, or any type of artificial intelligence technology. But what we have discovered, we start with pilots, small proofs of concept, to see how a particular technology that's mature can be applied to some of our current problems. And right now, we've done that with IBM's Watson down at Marine Corps Forces Command. They're the ones who kind of manage the globe, where we put people at what time, how many, based on missions. And it's doing very well. And business analytics usually has just, it does statistics on ones and zeros, yeses and nos, numerical. But the magic of Watson is that it can read, understand, make statistical or quantitative sense out of text and language. And so it can read things that people have written and then return intelligent conclusions that are very helpful to us. And the data sources that comes from, that's another thing, that's another issue altogether, but it works. And so Watson is a little magical in that sense. It's doing something with artificial intelligence, and it's mature, and it's commercial, and it's reliable, that on some issues that we were only able to do with our manual selves in the past. So the potential, the tremendous potential for all artificial intelligence technologies, but natural language processing in particular.
And so as you, just so the folks can understand, it's not only that we're bringing the technology to bear, and that's useful, but it's also a tremendous time saving, is it not? I mean, historically, a lot of this is done with spreadsheets and whiteboards and Post-it notes and a lot of people in the loop, as you said, that manual process, right? And that allows you, that's manpower intensive, number one. And number two, it only lets you look out so far in doing that planning process. So at the end of the day, what was the advantage that the natural language processing and the predictive analytics brought to bear for you?
For one thing, the information age is young. And so there's not that much data to look at yet, maybe 10, 20 years, some 30 years, that's been digitized to the point that we can actually ingest it to look at it with machines. But we're getting more. The main thing is the speed, of course. With business analytics, we can look at the past data, and we can do regression analysis where we look for patterns that have happened throughout the history of that data store that humans couldn't see. At least they couldn't see it. The human analyst wouldn't be able to pick that up. Perhaps in hours or perhaps days and months, where the machine can pick up those patterns instantly. Now, again, that's the business analytics piece of the ones and zeros, the statistics piece. But when it comes to natural language processing, we're looking at more than just that sort of data, where you have yeses and nos checked off on a spreadsheet. We're looking at what people said. And so I don't know if I'm using, maybe I'm making it up in terms of a term, but it's sort of an intelligence density per bit and per byte is so high in text compared to the other data that we have. It's absolutely the most valuable, byte for byte, the most valuable data is in the text, because that was intelligently put together by humans, by Marines, and it has great enduring value. So speed, first of all, but now that we're getting into the natural language processing of what's been written, we're getting insights.
And that's the key, and that's what that's exactly how we would say it. So you're not making it up. We would call it insights, the ability to understand the sentiment of what that human being put into that written word. And so at the end of the day, though, we're not using the AI to simply provide you an answer, push a button, black box words, and an answer comes out, right? I mean, what's happening is we're using the AI and the natural language processing to sort of do the grunt work, if you will, and as you said, surface those insights for an analyst then to take that and do the interpretation.
Well, at this point in history, the Marine, we talk about the Marine machine team. The machine is a subordinate assistant.
Right.
And even with the best Watson instance in existence, he's still going to assist, and the decision maker is still the Marine, and he can reject that assistance or accept it. The cognitive capabilities of the human they still eclipse anything that's out there. Maybe that'll change in the next few decades. But right now, we accept data. It's like a staff officer. Let's pretend the computer's a staff officer. Provides advice, but the commander says, my gut feeling, which means a lot in the Marine Corps, tells me I'm going to override your assistance. And that's still where we are at this point in technology history. This is still needed. And so the technology assists, the machines assist, but they do not make the decisions.
And that's certainly consistent with what we see around the world throughout industry as we're bringing our AI to bear. People talk in terms of artificial intelligence. We actually talk in terms of augmented intelligence, because that machine is augmenting the human. One of my favorite examples is over on the medical side of the world. Doctor error rates, somewhere in the 5% range. You bring in the AI capability, the error rate's actually worse. It's up at 7 or 8. But you bring the two together, and that 5 drops to 2 or 3%. And so it is that augmenting, that machine and human coming together in the loop to solve that. So
we call that combined arms in the Marine.
There you go. There you go. I'm a Navy guy, so
you do too. You do too.
So where do we go from here? What are sort of the next steps with respect to this program, or even beyond that? Where are the Marines looking to go?
Well, again, we're being very deliberate about it. And so we scale. The Marines need to have confidence in this new technology, because I said we're really good at manual methods, and you have to show us that it works. So we're starting very deliberately with this instance down at Marine Forces Command. But there are so many other things that, as I understand Watson, that it's ready to do right now, that's actually doing in industry, with logistics and manpower, even in the medical realm, in force preservation, which is something we're very, very concerned about, helping our young lads and lasses when they come out of combat. There's so many things that can be built upon on what we're doing now. And since it's an open architecture, and I'm learning some of these terms, so I don't know exactly what it means, but I know that we can plug and play other people's stuff. Right. That's the key thing. Watson is a narrow slice with this natural language processing. But then you have these other companies with these fantastic capabilities. I won't even name the companies. You know them all. That you put into Watson itself is an ensemble of algorithms. How about an ensemble of ensembles? And I know one company, they have a business analytics instance that is an ensemble itself. It's an ensemble of ensembles. When you put them all together, you have a really powerful capability. We see that coming. Right. We see that coming. Right. And we see that, and once it comes, we will scale accordingly. But again, we do not foresee machines taking over for the Marine decision maker.
Right. So we don't need to worry about that yet.
Not yet.
No, but I think you're spot on. And going back to sort of my opening introduction, I think that's exactly where we see the world going, and what we're calling Chapter 2, Cloud Smart. It is that hybrid cloud world. It's a hybrid AI world. It's bringing in, as you said, that ensemble of ensembles, because you want to pick the best, right? At the end of the day, we don't want to send our Marines into combat with the okay thing or the second best thing. We want to send them into combat with the absolute best at the end of the day.
Well, I'll give an example, sir. Until recently, I could ask some of my Marine brothers and sisters out there, but I think I'm pretty accurate. We've been dealing with overlay acetates.
I did a lot of that myself. I had grease pencils
in the CIC, right?
Yep.
And so the transparent sheet of plastic that usually kind of stunk, and you could draw pictures on that, overlays, put them on maps, put targets, all sorts of things, routes, boundaries. The amount of real intelligence that are in those simple symbols, and that we pick up on with our eyes. Intuitively.
Right.
And we do the statistics in the background. It's all subconscious. To be able to do that, that's a high bar. And so we'd like to get to that point, but we're not there yet.
Yeah, it definitely is, as you said, it's a long path, but when you think of the potential, and this is where I get really excited, because you brought up the natural language processing and the ability to understand sentiment. Well, what now if I apply that natural language processing to the training of my potential adversaries? And now I know, now I begin to train Watson as an adversary.
And now we get to one of the commandants, General Robert Neller, our commandant. One of his priorities over the last couple of years has been to develop a world-class wargaming center.
Exactly.
And that is where we are going to see the application of, it's a work in progress.
Absolutely.
So I can't speak for the program, but I can tell you artificial intelligence and machine learning is going to be a huge part of it. And yes, what goes into a war game? A red cell. So absolutely modeling the behaviors of others, but also in very, very realistic environments that we could only imagine, we could have only imagined a few years ago.
Yeah, it really is incredible when you think. I frequently get ahead of my headlights in thinking about the potential, and it truly is exciting. The younger folks in the room will be the ones to implement this, but it absolutely is the wave of the future, I think.
Yes, sir.
So, all right. Well, Franz, thank you so much. I think we're just about out of time. So,
okay.
Again, thank you so much.
Thanks a lot, sir. Appreciate it.
This endangered species is getting help from some unexpected friends. The zebra and antelope. They're wearing IoT sensors connected to the IBM cloud. When poachers enter the area, the animals run for it, which alerts rangers who can track their motions and help stop them before any harm is done. It's a smart way to help increase the rhino population and turn the poachers into the endangered species.